I will, as promised, leave this song on in the background. But I want to talk to you a little bit about the rest of class. Here's the plan. Wow, some deep sighs. Okay, thank you very much. On Thursday, I am recording. There are a lot of people who are absent today, so I'm going to put this up for them so that they can catch up on what's happening. So you're not in it. Only the voices are in it, and that's great. So, all right, ladies and gentlemen, we are going to do our pre-lab for Thursday's lab. The pre-lab is you figuring out, I know, it's kind of fun with the music, right? How can we predict acidity and alkalinity? Okay? How can we predict this if all we know is the structure of the molecule? All right? Good news is, in Unit 3, there's only 2 new things, pH and equilibrium. You already learned one. Bad news is, Unit 3 is a long unit because we're putting together almost everything you learned in Unit 1 and 2, except for gas laws. Yay! Thank you. Okay. All right, ladies and gentlemen, let's try this out. So, I'm going to do one example for you, and then one example with you. And I'm switching colors. Good. I'm going to do the sodium hydroxide example, and I'm going to do the hydrogen sulfate example. And I'm going to do these two. Here's what I want. If I give you the chemical formula, can you tell me, when I mix it with water, is it going to make an acid or a base? The good news is you can. You have learned enough chemistry to do this. The bad news is it is spread out literally all over your notebook. So, here are the pages you will need in order to figure this out today. Correct. It is spread out all over your notebook. You need to know how Bohr models work so that you can understand how valence electrons work. You need to remember how solutions work and electronegativity and how that connects to bonding and intermolecular forces and chemical reactions.
Can I write all that down?
I'll tell you what, I'll leave it on the screen for you. You may write it down, but I will also leave it there. Okay? All right, my dears. Let me start with an example. You ready? Yes? No? Potato? Something? Okay. All right, I'm going to take sodium hydroxide, and we're going to use this page for our scratch work today. So, NaOH. I'm going to mix that with water, and this is what you're going to do in class tomorrow. And what I want to know is, what did I just make? Was it an acid or a base? Well, turns out you can actually figure this out if you know enough chemistry. Cool. Why? Valence electrons. Let's just throw some vocab in there, see if it sticks. All right. No. But yes, when in doubt, the answer is electrons. So let's try to make the structure of this compound first. And then I'll show you either, y'all focusing? This is the most important part of today. Ready? Either this hydrogen is going to fall off and become H+, and then it'll be an acid, because it'll have H+ ions, or the O and the H are going to break off, and then it will be a base, because it will have OH- ions. Does that make sense? We got to figure, okay, I'll show you then. We're going to figure out which of those two things is going to happen. So first, I've got sodium, I've got oxygen, and I've got hydrogen. First things first, I need to know what kind of bonds these are going to make so that I can figure out which of these bonds is going to break so I can figure out if hydrogen or oxygen is going to be on its own. How do I figure out what kind of bonds these are going to make? Just doing a gentle hint over here as I bring this back to the screen. Okay, we could look at bonding. A great start. Hey, what determines bonding? Why don't we turn to page 26 and 27 and find out? Everybody turn to page 26 and 27. Take a look at 26 and 27. What determines what kind of bonds we make? Okay, well that page tells us about the two different types of bonds that might happen, ionic and covalent. Take a look at the previous page. How do you decide if it's going to be electronegativity? Yes, it's been a minute. Do you remember? Don't answer that question. Okay, here we go. So, what is the electronegativity of sodium? Take a look at your table. Hey folks, I want to see everybody turning to these pages. We're on page 24 right now. What's the electronegativity of sodium? 0.9? 0.9, okay. So sodium The electronegativity is going to be 0.9. How about oxygen? What's the electronegativity there?
3.4.
Okay. Electronegativity 3.4. How about hydrogen?
2.2.
Electronegativity 2.2. Okay, very nice. So let's think about this. We know that hydrogen can only form one bond. How many bonds can oxygen form?
6.
No, that's how many valence electrons it has.
Oh.
Actually, why don't we draw valence electrons just so that we're all on the same page? All right, there's my valence electrons. How many bonds can oxygen form? 2 covalent bonds. Okay, hydrogen can only form one, but what if oxygen and sodium form a bond? What kind of bond is that going to be? All right, let's find out. What is 3.4 minus 0.9? 2.5. All right, you tell me. Is that going to be ionic, polar covalent, or nonpolar covalent? What did you say it was? 2.5? It's ionic. It's going to be ionic. That's right. So when we have an ionic bond, page 26, we transfer electrons. We're not sharing, we're transferring. So let's transfer this electron from here to here. Okay, now sodium is going to be positively charged, and oxygen is going to be negatively charged. How about oxygen and hydrogen, though? What kind of bond are they going to make? 1.2, okay. What is that? Polar covalent. So they're actually going to share. So here's what we're going to end up with here. Is a covalent bond here and an ionic bond here. Well, that's the question. If this bond breaks, then we get an OH minus ion. If this bond breaks, then we get NaO and an H plus ion. So I need to know which of these is going to break first. Remember, we're dissolving this in water. What makes water so good at dissolving things? Wow, great question, Miss Iyer. It kind of has something to do with solutions. It's been a long time. Why doesn't everybody turn and take a look at page 39, where there are solutions? Turn to page 39. What makes water such a good solvent? It is an excellent solvent. What makes it such a good solvent? Remember these charges, partial charges?
It's not conductive. Hydrogen bond not conductive.
It's not conductive, that's true, but what makes it such a good solvent, guys, is that it has positive and negative charges. Partial positive, partial negative. That means that it can pull apart things that are charged. So, you tell me, which bond is going to break? The one that's created from opposite charges that are sort of being attracted to each other? Or the bond that's created by sharing electrons? Yeah, the opposite charge bond is going to break. When in doubt, ionic bonds are the most likely to dissociate. So let's add a little note for ourselves there. I'm going to put that star right there. Ionic bonds dissociate. And we actually learned that. Oh gosh, what page was that on? That was a million years ago now. Dissociate. It was the page with the human body on it.
I don't remember the human body.
No? Was it 37? You're right, 37.
Oh, I love this.
Okay, so if ionic bonds are the ones that break down in water, what are my products going to be?
What did you say?
what are my products going to be? If I mix these two together and this bond breaks, what am I going to make?
O2H3.
Oh, you're doing, nice job. You're doing a double replacement. It's actually a little bit simpler than that one, although it may end up more complicated eventually. Na plus plus OH minus plus there'll be some H2O left over. So you tell me, folks, is this an acid or a base that we just made? Connor, I see you mouthing the word base at me. Jack, I see you mouthing the word acid at me. Guys, take a look. Do you see anything here that we usually associate with acids or bases? Maybe you want to really quickly take a look at this page? Hey folks, when it's an acid, what do we see a lot of? H plus ions. When it's a base or an alkaline solution, what do we see a lot of? Okay, so you tell me, what did we just make? We made a base. Very nice. Do you see how we figured that out?
Yeah.
We just figured out which bond is going to break. Is this one going to break and we get an H plus ion? Or is this one going to break and we get an OH minus ion? So we're going to predict that this is going to have a pH greater than 7 because it's going to be a base. Shall we do another one?
Yeah.
Yeah? Okay. Let's do the H2SO4 one. Okay. Say it again. No, that's going to be from the lab tomorrow. During the lab, you'll actually try this solution with an indicator strip and tell me what's the color and what pH do you estimate. And we'll see if your predictions are correct. Okay? That's the plan for the lab tomorrow. It depends on the strength of it. It depends on how concentrated the hydroxide is or how concentrated. Honestly, it just depends on what I mix up in the morning.
Please make something nasty.
You're looking for something really dangerous?
Yeah.
Something that'll definitely get me fired?
Yes.
All right, all right. I'll try to stop being so selfish and see what I can do to get myself fired. Here for you.
No, wait.
All right, ladies and gentlemen, so we can actually skip this part where we make this whole chemical reaction. We can just make the structure and figure out, does a hydrogen ion come off or does a hydroxide ion come off? Yeah, we really can. Ready? So here we go. Next one we're going to do is H2SO4. All right. Let's look up our electronegativities first this time. I think it'll make our lives a little bit easier. Okay? Okay, so the electronegativity for hydrogen is 2.2. How about sulfur?
2.6.
Okay, electronegativity for sulfur, 2.6. And oxygen is still 3.4. All right, what kind of bonds are we going to see in this?
Polar covalent.
Okay, we're going to see a polar covalent if sulfur and oxygen make a bond. And we're going to see non-polar covalent if hydrogen and sulfur make a bond. Okay, so now we just have to figure out how they actually bond. Guys, when they write these, they're usually giving you a hint. They're showing you something about the structure a little bit.
There's 2 hydrogens, 4.
2 hydrogens, we got 4 oxygens. What's in the center?
1
1 sulfur.
So that one's probably going to be the...
Okay, so let's draw our sulfur in the center. Now, sulfur's a little funky. It has structure just like, or valence electrons just like oxygen, but because it's lower in the periodic table, it can actually form some kind of funky bonds. So I'm going to tell you right now, it forms a weird double bond with its oxygen, with 2 of these oxygens. But here's the good news. Even if you messed this up and did a different kind of structure, you could still figure this problem out. What next? What else do I need to add to this?
Your hydrogen, and the hydrogen's just going to be on the left and right.
Okay, well, hold on. How many oxygens was I supposed to have?
4.
4. Okay, so I've got 2 already.
So connect to other oxygen.
Okay, so we got 2 more oxygens here. I don't want to wait and do oxygens at the end because hydrogen can only bond to one thing, so it's probably going to be on the edge of this molecule. All right, and then I've got my hydrogens. They each get one little lonely electron. All right, what would you do for bonds now?
Link the hydrogens to the oxygens.
Okay. These guys are going to share electrons. There's a covalent bond. What else would you do?
Double bond the oxygens to the sulfur.
Double bond oxygen to sulfur?
Or the first, is it just single bond?
Yeah, we can just do a single bond there because they each have one lonely electron. All right. Now here's the issue. These double bonds are not going to break. You're never going to have water pulling apart a double bond except in some really odd chemistry. So it's going to be one of these two bonds. But they're both covalent bonds, so how do you know which one of these is going to break? Weaker is one way to think of it.
Higher.
Whichever one has a higher difference in electronegativity. That's the one with higher charges. That's the one that's easier for water to pull apart. So, go ahead and calculate your electronegativity differences.
So it's
Grab a calculator. Do it. You're going to practice now or practice on the summative. What's the difference in electronegativity for this bond? What's the difference for this bond?
1.8 or 1.2.
What's this one?
Sulfur to oxygen.
Oxygen. That would be, let's see, 2.6 minus 3.4, or 3.4 minus 2.6. So yeah, that's going to be 0.8. And this one?
1.2.
1.2. Okay. If you have two covalent bonds, whichever one is closer to being ionic, that's the one that's going to break. So in this case, which one's going to break this time? That's right. It's going to be the bond right here. This bond is going to break. When it breaks, what are we going to get?
But whichever one's closer to what is going to break?
Whichever one is more ionic, has more ionic character. It's basically the bigger number is going to break.
Yeah.
Okay? Hey guys, when this breaks off, what do you have?
You'll have the acid.
H plus. You tell me, is that going to be an acid or a base?
Acid.
Okay. If this bond had broken, what would you get? That's right, it'd be an OH that came off, and that would be a base. All right, so remember, the reasoning here is that anytime something has a higher concentration of H plus, it's an acid. Anytime it has a higher concentration of OH minus, it's a base. All right? So, on this one, I'm going to predict my pH to be less than 7. Next up, I'd like you to try this with your neighbors in kind of a different way this time. I want every single human at the table to pick one of the 4 remaining ones. It all has to be different. Okay? And actually, to make this make a little bit more sense, I'm going to have you two join that table for now. Okay? So hop up, head to that table. Everybody pick one of these 4. Okay? And I want you to take about 2 minutes to get started trying to figure out the structure, the electronegativity, valence electrons. You're going to get started on your own. So, talk to your table, decide which one you want to pick. Once you pick one, I want you to take 2 minutes by yourself and get started on this problem. If you don't know how to start, just start by writing the atoms.
It sounds like this is a robot from
So, we're doing this or this. Alright, we can all this.
Oh, okay.
Are these pages?
Oh, yeah.
Well, okay, so
The last one.
I'll do CaO2.
All right, so how do you start? First, write your atoms. Remember, this is HCl, so a hydrogen and a chlorine. Write your atoms. You're doing whichever one you picked. Which of these 4 did your table get? Did you pick? It's different from the rest of the people. So which one did you pick? Wait, they do have this one.
This one is very similar to this one.
Yeah.
Oh, this one's great.
Figure out now.
Yes, sir.
So,
Correct. Yep. Same exact kind of thing.
The only thing I definitely think is where did you get H to it? Yeah, if the second one, yeah,
Let's figure out the electronegativities. It's actually yours to figure out what. But yeah, figure out the electronegativities, figure out where the bonds are going to be, figure out which bonds are going to be.
the only thing I know what to say is because I'm trying to reference your eye. But I don't understand this how this just kind of spawned out of nowhere.
yeah.
Things spawn out of nowhere. These are chemicals and we're mixing them with water. So that's the lab. Is we're going to keep
Okay,
mixing these with water. Yeah.
Okay.
So KOH is going to look like this one.
Okay.
All right, my dears. Now that you've had a chance to think about it, no, we're not done yet. But I want you to get a chance to team up with people. Okay? So, every single human that picked KOH, I want you to come to this table right here. Every single human who picked KOH, you're going to come to this table right here. Every single human that picked HCl, we're going to come to this table right here. Every single human that picked H3PO4, you're going to come to this table right here. And every single human that picked CaOH2, we're going to come to this table right here. All right. So once again, KOH there, HCl here, H3PO4, and CaOH right there. Right there. That's right. I want you to talk with your table and figure it out together.
Yeah, I got the
Talk with your table and see if we'll figure it out together. Now what?
I'm not using it.
That's like figure out the valence electron and like try to put it.
Okay, there we go.
So I guess like hydrogen. That's gonna have one.
Oh, so one.
It's gonna have one. It's gonna have.
All right, my dears. I want to get some predictions from you. So let's take a look. My KOH group. What do you think is going to come off of this? Is it an H or an OH? My KOH group. What's going to come off of this? H or an OH? So I saw your paper looked fabulous. Can I borrow your paper, Jaden? Can I borrow your paper? I think you guys are overthinking this a little bit. Let's take a look.
I know it's
Okay, so these are both polar covalent. Oh, you can't see. These are both polar covalent. Is that true? 3.4 minus 0.8, what's that? 2.6. So I think this one's actually going to be ionic.
Yep.
So this one's going to break. What are you going to get over here? You get an OH, right? All right. Thank you, beautiful. That was so beautifully written. It's easy to see. All right. So my prediction then, if an OH is going to come off of it, what do you think? Acid or base? Base. Anytime you see an OH, we should be thinking base. So in that case, the pH is going to be greater than 7. How about my HCl group? What do you think?
It's gonna be an acid.
Going to be an acid. That hydrogen's going to come off. Good. pH then is going to be less than 7. How about my H3PO4 group? What do you think? Acid. Okay, so my pH is going to be less than 7. How about my calcium hydroxide group? What do you think? Base, all right. pH is going to be greater than 7. And here's the thing. These are just predictions. We're going to try them out tomorrow. Now, I want to show you a special case. How about this one down here? Sodium chloride. Sodium chloride. What do you think? What's different about this than the things we've looked at before? Yeah, there's no hydrogen. So can you have H plus or OH minus coming off of this? Okay, so if you can't have, hold on, don't overthink this. If you can't have extra H plus or extra OH minus, what do you get? Correct. So my bet is that the pH for this is going to be about 7. How about this one here, MgSO4? No hydrogen means no H plus and no OH minus, right? All right, once again, I think we're going to see a pH of about 7, at least based on the rules of base, acid and base I've taught you so far. Okay? Now, this next one's a little weird. Let's actually take a look at this bottom one right here. All right, I would never make you figure out the structure for this. You could, but it would just be a lot of work. So I'm going to let you look up the structures for this one, this one, this one, and this one. All right, you're only going to pick one for your table to work on. I want you to look up the structure, and I want you to figure out, based on those bonds, are we going to have a hydrogen coming off of this or an OH coming off of this? Okay, so I'm going to let you just pick one as a table. Let's think. Which one do you guys want? Okay, so you guys are going to get this one. Which one do you guys want?
The last one.
The last one, right? You get this one. Zeke and Nash, I'm going to have you join this table again. Which one do you guys want?
We can go CH. Oh,
Which one do you want? This one or this one?
the second one.
The second one? Okay, you guys get this one. That means my back table gets this one. Okay? Look up the structure, and then I want you to figure out, is it H or OH that's going to come off? Look up that structure. As soon as you and your table have figured it out, yes. Yes, please look up the structure, and then you can use electronegativity to figure out which of those bonds is going to break first.
100%. This one? Yeah, for sure. 100%. Yep.
Somebody grab an iPad, look up the structure, show your whole table. And based on that structure, I want you to figure out which of these you think it's going to be. These will be our predictions, and then we will test these in our lab on Thursday.